UPI Fraud Detect, an intelligent ML and DL based system for identifying anomalies in UPI payment network. The project focuses on detecting fraudulent activities in UPI payment systems such as advanced machine learning and deep learning techniques. With rapid growth of digital payment, fraud cases such as phishing, SIM swapping, and account takeovers are increasingly significant. Traditional rule-based system fails to identify such cases and such fraud patterns. The proposed system aims to protect the real-time fraud detection while maintaining the accuracy and minimizing the interruption to genuine user. The proposed system combines multiple ML and DL based systems such as XGBoost, CADBoost, Isolation Forest, and LSTM autoencoder and graph neural network to identify the fraudulent UPI transaction effectively. Synthetic transaction data containing different fraud scenarios is used for training while preserving the privacy. Sharp explainability is also integrated to provide a transparent and understandable prediction. The literature survey analyzed several recent fraud detection studies using ML and DL based and AI based technique, and existing work mainly used model like logistic regression, random forest, XGBoost, and ensemble methods for banking, credit card fraud detection. Most studies achieved very good accuracy but struggle with high false positives and poor adaptability to new fraud patterns and insufficient temporal analysis. Researchers also highlighted issues such as class imbalance and lack of real time detection capabilities. These limitations motivated the development of a more robust and hybrid detection framework. The major issues and challenges. The fraud detection system faces a major challenge due to scarcity of labeled transaction data and high cost of manual annotation. Traditional methods fail to analyze a large volume of unlabeled transaction data effectively. Existing systems also struggle to identify a complex multi-hop fraud detection and hidden risk structures. Coming to system, this is a architecture diagram. Coming to system requirements and tools, the project is developed using Python based tools with Anaconda and Jupyter Notebook, and libraries such as Pandas, NumPy, Scikit-learn, and XGBoost and Imbalance Learn are such used for pre-processing, model training, and data balancing. We develop the front end using HTML and CSS, JavaScript, handle the front end, and for database we use SQLite to manage the transaction records. Coming to the first module of the project, it's data pipeline. The module generates and pre-processes the synthetic UPI transaction data for training the fraud detection system. Since a real financial data is very sensitive and realistic synthetic data sets are created with both normal and fraudulent transaction. Different fraud scenarios such as phishing and mule accounts are simulated to improve the learning capabilities. Here comes a second module of feature engineering. Feature engineering converts a raw data transaction records into meaningful numerical features for model training. The model extracts a time based pattern, transaction frequency, spending behavior, and network related information. It also generates a sender behavior and device related features to improve a fraud identification. A third module is model training, which is hybrid models. This model train multiple machine learning, deep learning, and anomaly detection models simultaneously. Supervised models like XGBoost and CADBoost learn transaction classification pattern, while Isolation Forest and LSTM autoencoder identify unusual behavior. Here comes a fourth module, weighted ensemble along with explainability. The ensemble model combines output from all the trained models into a final fraud probability score. Each model is assigned an optimized weight based on its performance contribution. Sharp explainability techniques are used to provide a feature level explanation for every flag transaction. Here comes the last and final module, API servicing and real time dashboards. This model handles real time fraud prediction and deployment. API endpoints are created to process the incoming transaction request and return fraud scores very instantly. The system performs a feature extraction and model inference in real with minimal latency. Here are the implementation screenshot of a project. And Here are the four main reference papers of the project. Let me take you through the deployed final project. Yeah, this is a final project. First is like overview dashboard. This is the main dashboard. So when a transaction start coming in, you can see everything here. How many were checked, how many got flagged as fraud, and how many were safe, and the total money involved in the transaction. These charts on the side show the risk distribution, like how many transactions fell in low, medium, or high categories. This is the entire overview page of a project. Next come the transaction checker. So here you can manually enter a transaction and check if it is fraud or not. You can put up things like amount, type, a new payee or not, or day, transaction last, and sender average, and things like that. You can also make use of these buttons to autofill the datas instead of manually putting. Once I'm clicking on phishing, uh, the values will get uh, automatically put into the field, and we can click on analyze transaction to analyze the transaction. Yes. So we are getting a threshold of above 50%, so it is being flagged as fraud detected. And here we could see the AI explanation of the system of why it is being flagged as fraud, and also we could see the sharp explainability of the system. Since it is flagged as fraud, the major score being given to is new payee, and accordingly the model's agreement of this fraud has been given here, and we could see the fraud archetype right here. And since we have clicked on phishing, the 95 percentage of score goes for phishing, and the archetype falls under phishing archetype. And here we could see the 5 feature engineering model graph. And next is live monitoring. In live monitoring, um, we could send a batch of 10, 20, and 25 models, and detect it very fastly. This feeds updates in the real time. The transaction feed will get updated real time once the model is checking. And we could also see a live alert if some transaction in the batch is flagged as fraud. I will send a batch of 25 and let you know on how the system work actually in live monitoring. We are sending a batch of 25, and here we could see the transaction feed being updated quickly, and the status is being updated right here in the transaction feed uh, in live. And uh, in batch of 25 we could see like one transaction has been flagged as fraud, and that transaction will be right here in live alert as well. And we could see the total summary at the top of this with a session total of 26, along with fraud code 2, and fraud rate as 7.7%, the average score being given here. So here we have documented how the model actually performs. The ensemble model were able to achieve a AUC ROC of 0.99%, AUC PR of 95%, and recall of above 90% plus, which is a very good number for a fraud based detection project. And also we could see the uh, individual model outputs right here. Yeah, that's it. And in model comparison, we have documented all the metrics that were associated with each model, and we have given the last output of our project and our ensemble model as well. And in fraud alert, we could see the alert which we got in live transaction as fraud. uh, I think you remember, like we got one transaction as fraud in a live monitor that been documented here as like first thing. Transaction checker thing, we could see the AI analysis of the particular live transaction live transaction datas, and we could also export this as an CSV file later for our reference. Yeah. That's a UPI Shield core. The core idea um, was to make the transaction was to find whether the transaction is a legit or a fraudulent transaction, and also we want people to know on why the particular transaction being flagged as fraud using an AI explainability, and also we were able to get a recall of like above 90 percentage, which is very great number for fraud detection project. uh, I hope this system help people to find the patterns and bank to find the patterns very early, and they could reduce uh, fraud fraudulent activities with the patterns. And yeah, that's it. Thank you.